Welcome to the ABB e-learning program for WirelessHART instrumentation. This course module will introduce you to the basic network design. After completing this module, you will be able to describe how a WirelessHART gateway operates, locate a WirelessHART device correctly, explain how the WirelessHART signal is sent out, apply the basic design rules. Now we've learned a lot about WirelessHART, we should take a look at its infrastructure. The WirelessHART gateway is the core element of a network. It contains a network manager and a security manager. The network manager takes care of the wireless communication between the WirelessHART field devices. It also creates and maintains the mesh functionality. The security manager distributes the encryption keys, which as an option could be changed at random intervals. Remember, to make communication safe, all messages are encrypted. Regarding the gateway interface to the control system, most WirelessHART gateways offer RS-485 as well as Ethernet. Both interfaces transmit the HART or Modbus protocol. OPC connectivity can be realized via a HART OPC server. It can be configured via a Device Type Manager, DTM, or a Device Description, DD. Furthermore, most gateways provide a web interface for direct access via a web browser. The WirelessHART gateway caches parameters and dynamic values and makes them available to the host. Usually the WirelessHART gateway is placed first, as this is the core element of a WirelessHART network. There are three basic options for placing a WirelessHART gateway: where it is easiest to integrate with the system or plant network. Usually this is the control building or another structure. This results in the shortest possible cable run for the wired interfaces of the WirelessHART gateway. Central to the planned network. Placing the WirelessHART gateway in the center provides the best position for most of the devices to have a direct communication link with the WirelessHART gateway. This location ensures the highest reliability. Central to the process unit. This location provides the most flexibility for future expansion of the initially planned network to other areas within the process unit. With this solution, the highest possible degree of flexibility is achieved. Finding a location for the gateway may not be too difficult. These days, gateways need to be installed in safe areas, where there is a 24-volt power supply and a host interface network is available. Of course, all the devices in the network must comply with the WirelessHART specification, with a certificate from the HART Communications Foundation. This will provide confidence that these devices will operate correctly in the network. A gateway can support up to 250 WirelessHART devices. The achievable update rates depend on the number of devices in the network and the network structure. For example, with a network of 100 devices, update rates no faster than 8 seconds are achievable. If the application has more devices or needs faster update rates, then another gateway is required, which can be operated in parallel with the first one. Gateways can have overlapping networks. However, users need to make sure that each network has a unique network ID. The join key could be the same. What have you learned so far? A WirelessHART gateway needs Ethernet and a 24-volt power supply to operate. Data is cached and provided via HART, Modbus, or OPC. Locating the gateway must be well considered, depending on the need for less cabling or highest flexibility. Up to 250 devices can join one gateway. The actual amount depends on the update rates. Like any wired device, the WirelessHART device can be positioned in accordance with the requirements of the measurement task. Nevertheless, some aspects in the direct vicinity of each field device must be considered in order to ensure optimum wireless communication. Mount the devices at least 0.5 meters from any vertical surface, for example, wall, to avoid near-field reflections which can disrupt radio communication. Mount the devices at least 1.5 meters off the ground to minimize ambient effects. Ensure that the devices are at least 0.5 meters apart from each other to avoid crosstalk. Make sure that the device's antenna is aligned vertically for best results. The WirelessHART gateway antenna spreads the signal in all directions. The antennas of our WirelessHART transmitters also do this, but the housing can seriously affect the signal. ABB devices feature directional antennas, such that they point at the gateway or at the next device in line of sight. This is a plus, considering all the possible obstacles at a plant. Despite the main signal direction shown here, it is still possible to receive a signal from the back. The vertical characteristics of the antenna should also be considered. The gateway provides the strongest signal transmission within a range of ± 45 degrees. Our WirelessHART devices provide their best signal strength within a range of ± 30 degrees. Knowledge of signal transmission ranges is important because it can help when placing devices at different heights. Here we can see an example installation where the devices are not all placed at the same level. If we consider the theoretical signal irradiation, the WirelessHART pressure transmitter can communicate with the gateway. The link between the temperature devices is likely to fail instead. This is less critical in the horizontal plane, but remember, to get the best communication link, antennas should face the direction in which the closest device is placed. This is to be considered in case any obstacles block other links. What have you learned so far? A WirelessHART network is easy to implement. There are a few metrics to consider when placing a device. The antennas provide a main signal direction, which should be considered to ensure a successful network design. While the antenna provides a main signal direction, it can still receive from all other directions. So far, so Now we've described signal irradiation and device behavior, let's talk about the distance range that we can expect. Since a plant may vary in its density, sectioning it will help to achieve expected network behavior. We can see here a satellite picture of a typical plant, which we can section into 4 categories. Line of sight, where there are no obstructions in the line between devices, which would be the most desirable situation. Low obstructions. In this area, some infrastructure exists, but in this mostly open area you can still see from one device to multiple other devices. Medium obstructions. This is a denser environment, but there are still rather large areas that are not obstructed, such that a truck could be driven through. High obstructions. In this area we have significant metal and structural material that blocks the view from one device to another. These simple rules allow the easy identification of the different areas of a plant without extensive detailed analysis and site surveys. A walk through the plant will give you enough information to identify the density with which you will be working. This picture is an example of what 2 different density environments would look like. Above the blue line is a line of sight or low obstruction environment. The WirelessHART signal could carry up to 250 meters if the devices are above all the piping, maybe a bit less if they are located in the upper pipe racks. Below the blue line is a high obstruction environment. In many plants, this will be where the majority of the devices will be located. Having a direct line of sight is the best option for any radio link. However, this is not always possible in a real plant. Here some direct paths will be blocked, and it will not be possible to receive the signal from the gateway. Other signals will be reflected in an unpredictable manner by the surrounding environment. At the very least, signals get scattered when they strike structures like grids or even trees. This means that the path of a signal could easily be more than 200 meters, while the separation distance is just 30 meters. Additionally, the signal gets attenuated by the material it must pass through. As you can see, signal strength can decrease significantly if there are brick or concrete walls between the field device and the gateway. Ground and metal surfaces absorb the signal, which reduces the wireless communication link. But how do you rate the quality of a signal path? The gateway provides statistics. At first, there is the Received Signal Strength Indicator, RSSI. The RSSI indicates the power of the received signal for each device. The higher the RSSI number, the stronger the signal. A value greater than -75 dBm is good, while best practice is to aim for an RSSI no worse than -60 dBm. The next indicator is the path stability. The path stability is the ratio of successful data packet transfers to the total number of data packet transfers on all wireless paths in the network. General requirements are 60% path stability, but 70% is recommended for control and high-speed monitoring. Reliability is a statistic data expressed in percentage and is roughly the amount of expected information received by the gateway. The expected value should not be lower than 99%. What have you learned so far? Areas for WirelessHART networks can be separated into 4 density areas. The wireless signal will behave differently in a plant. It can be blocked, reflected, or scattered. This will lengthen the path it will take toward the gateway. RSSI, path stability and reliability are key metrics to rate the quality of a signal path. So far so good? Let's have a look at how to design a self-organizing mesh network to ensure the reliability of each communication link. There are 4 fundamental network design rules. Number 1. Rule of 3. Each WirelessHART device should have a minimum of 3 neighbors within effective range represented by the blue circle. This ensures that there will be at least 2 connections and the possibility for connections to change in time. Of course, devices will work with just 1 or 2 neighbors, but with less redundancy and diversity. While this is acceptable for single devices, this is inadmissible for routing devices. A pinch point like this can be mitigated by adding additional WirelessHART devices to work as routers or repeaters. Number 2. Rule of 5. Every WirelessHART network should be built with at least 5 WirelessHART devices. Networks will work properly with less than 5 devices, but will not benefit from the intrinsic redundancy of a self-organizing mesh network and may require repeaters. Keep in mind that there could also be moving obstacles. In a well-formed, well-designed network, new WirelessHART devices can be added to the interior or perimeter of the network without affecting operation or extensive consideration for design. Number 3. Rule of percentage. As networks grow, Rule of 3 and Rule of 5 become irrelevant, as there are many devices in the process space. A new rule becomes dominant to ensure there is enough bandwidth for all devices in the network. Every WirelessHART network with more than 5 devices should have a minimum of 25% of devices within effective range of the gateway to ensure proper bandwidth and eliminate pinch points. WirelessHART networks can work with as little as 10%, and actual implementation may yield less than 25%, but experience shows this is a practical number. Networks with more than 20% of wireless devices with an update rate of 2 seconds or faster should increase the percentage of devices in direct connection with the gateway from 25% to 50%. Number 4. Rule of maximum distance. Wireless devices with update rates faster than 2 seconds should be within 2 times the effective range of wireless devices from the gateway. This rule maximizes speed of response for monitoring and control applications requiring high-speed updates. If a wireless device requires update rates faster than 2 seconds or is used for control and does not meet the rule of maximum distance, consider adding a gateway or moving the existing gateway closer to the wireless device. If the process control loop is tolerant of latency, or if it was previously a form of manual control, it may be acceptable to have devices far away from the gateway. What have you learned so far? Each WirelessHART device needs 3 good neighbors in effective range. Each WirelessHART network needs 5 devices in effective range of the gateway. Each WirelessHART network shall have at least 25% of devices in effective range of the gateway. WirelessHART transmitters with update rates faster than 2 seconds must be within 2 times the effective range of the gateway. So far so good?